All right, before I get into the exterior angle theorem, I need to first tell you what an exterior angle is. So if I have a triangle, let's do this color. I've got a triangle. An exterior angle is if I took one of the sides and extended it, okay? And then the angle that is between that extension and the side of the triangle is an exterior angle. So this is an exterior angle. Okay. If I drew another example, I might have this triangle. If I extend this side, okay, then the exterior angle is again just this side right here. Okay. It's the angle that's created from the extension of that line. Okay. It's going to be the side that's closer to the triangle. So it's not going to be this huge side on the left. It's going to be the side that's closer to the triangle. So if I wanted to do that other exterior angle, then I would extend the other side of the triangle. And then this would be another exterior angle. Okay. Okay. Each triangle has 3 exterior angles, one for each corner. All right. All right, so then let's talk about the exterior angle theorem. All right, the exterior angle theorem says the measure of an exterior angle is equal to the sum of the 2 non-adjacent angles. So let's say I make this exterior angle over here. I extend that bottom line. And then my exterior angle is this one right here. This says that this exterior angle x is equal to the sum, which means addition, between these 2 non-adjacent angles. And non-adjacent just means the ones that are not touching that exterior angle. So they equal 87 degrees plus 46 degrees. So angle x is going to equal the sum of those 2 that are not touching it. All right, so that's the exterior angle theorem. All right, and then the last thing that I'm going to talk about is corresponding parts of a triangle. I'm going to start a new page. Okay, I'm going to start with this nice abbreviation that I have. It's CPCTC, and this means that corresponding parts of congruent triangles are congruent. CPCTC. So this means that if I have 2 triangles that are congruent, then the pieces of them are congruent also. So if 2 triangles are congruent, then the pieces are congruent as well. So I'm going to draw 2 triangles and we're going to label the congruent parts. All right, I've got triangles ABC and DEF, and they're congruent triangles. These are congruent triangles. So then if we're trying to identify the congruent pieces of these triangles, I could say that angle A is congruent to, which angle on DEF looks like it's congruent to angle A? Angle D. They are corresponding parts. You'll also notice that they're also the tips of these triangles. Okay. The shortest side, CB, is congruent to the shortest side on the other one, which is EF. Again, they're corresponding parts, and you'll notice they're the shortest side on each triangle. Okay, so as soon as you have congruent triangles, you can find their corresponding parts and say that they're congruent. Okay, so if I gave you a drawing that didn't have it labeled like this, but I told you they were congruent, you would be able to find the angle measures. Let's try one. Okay, so for this one, I don't have anything marked, but I did get this statement that tells me which things are congruent. So for this, in order to identify the congruent pieces, I can line them up. So this first angle is K and this first angle is J. That means that K is congruent to J. The second angle is L and the second angle is H, which means those 2 angles are congruent. The third angle is M and the third angle is I, which means those are congruent. Okay, and then I can look at each of these segments. KL and JH should be congruent. Then these ones, and then these ones. All right, and it came straight from that statement that it gave me. All right, that's it.